In this video, we are going to look at graphing rational functions. In our last video, we looked at when a rational function has a vertical asymptote. And our first blue box here talks about the vertical asymptote. So the line x equals a, you include the x, is a vertical asymptote of a function as it approaches, as if y approaches positive or negative infinity, as x approaches a from the right or from the left. So here we have a graph approaching x equals a from the right, and it's the y value of the function is approaching positive infinity. So this is a vertical asymptote. Here we have the line x equals a once again, but my curve is approaching it from the left to infinity. In my next two, I'm approaching x equals a from the right, and the y value is going to negative infinity, or my curve is approaching it from the left, and the y value is going to negative infinity. Now the line x equal or y equals b is a horizontal asymptote, so this is the first time we're getting an introduction to this. If, as y approaches b, x is approaching positive or negative infinity. So here, as x approaches positive infinity, my curve is approaching some horizontal value, y equals b. And in this one, as x approaches negative infinity, my curve is approaching some line y equals b. Now you notice here that a curve can cross a horizontal asymptote, but it cannot cross a vertical asymptote. So how can we find our horizontal asymptotes? And finding a horizontal asymptote is actually an easier process than above. We just have some criteria to remember. So if you have a rational function when the numerator and denominator of the rational function have the same degree, then the line y equals a over b is a horizontal asymptote, where a and b are the leading coefficients in the numerator and denominator respectively. So I'm going to jump down to example 3 here, because this is an example of this. In example 3, we have f of x equals a negative 7x to the fourth minus 10x squared plus 1 over 11x to the fourth plus x minus 2. Now, both of these have the same degree. Both of these functions have the degree of 4. So that's what we're talking about in A, when the numerator and denominator have the same degree. Now, my horizontal asymptote will be y equals, in this case, just the coefficients of these two lead terms. So a negative 7, that is my horizontal asymptote. It's a little wonky, but that's it. That's all we have to do. Now, if we look at the second criteria, it says when the degree of a numerator of a rational function is less than the degree of the denominator, then the line y equals 0, which is the x-axis, is the horizontal asymptote. Looking at example 4 is an example of that. So here we have in our numerator of the function f of x, 2x plus 3, and in the denominator we have x cubed minus 2x plus 4. So here my lead term in my numerator has a degree of 1, and my lead term in the denominator has a degree of 3. Since 1 is smaller than 3, this tells us when the degree of the numerator is less than the degree of the denominator, the line y equals 0 is the horizontal asymptote. That's what's going on here. So y equals 0 is my horizontal asymptote. So let's look at our third criteria here. It says when the degree of the numerator of a rational function is greater than the degree of the denominator, then there is no horizontal asymptote. That's going on in example 5 here. Here we have for f of x, it equals 2x squared plus 3x plus 1 over x minus 2. So since the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. But it does meet criteria 4 here, which says when the degree of the numerator is 1 more than the degree of the denominator, then there exists an oblique or a diagonal asymptote, which would be the case here because 2 is 1 greater than 1. But we don't have to find it in this case. So instead of graphing problem number 6, we're going to go ahead and do that eventually. Let's identify some things about it, and then we'll graph it later. Let's first find the vertical asymptote. From our previous video, we know that to find the vertical asymptote, we set the denominator equal to 0. So if x squared equals 0, you take the square root of both sides and find that x equals 0 is your vertical asymptote. So here we're not going to touch this. This just guides us. This is our vertical asymptote. X equals 0. Now, our horizontal asymptote is going to be found. In this case, they both have the same degree exponent. So we are looking at this first criteria. When the numerator and denominator of a rational function have the same degree, then the line y equals a over b is the horizontal asymptote, where a over b are the lead coefficients. So in this term, or in this function, 2 over 1 would be my horizontal asymptote. And that would be y equals 2 over 1, which is the same as y equals 2. So we have that going here. That's my horizontal asymptote, y equals 2. Now, before we try to graph the rest of this, we're going to look at some graphing techniques which are listed below. So let's keep doing that. So this talks a little more about asymptotes. Let's skip down to our ways of graphing a rational function. So our second box here says that the rational function p of x over q of x, we find any real zeros of the denominator, and that will sketch our vertical asymptotes. We did that for the previous problem. Then we find any horizontal or oblique asymptotes. We did that. Now we find any zeros of the function. So it tells us here the zeros are found by determining the zeros of the numerator. These are the first coordinates of the x-intercepts of the graph. Then we substitute 0 into the function to find the y-intercept. Then we might want to find any other values to determine the general shape. Now, for problem number 6, we already found our vertical and our horizontal asymptotes. So let's find our zeros. Once again, it tells us to find the zeros by finding the zeros of the numerator. That means setting the numerator equal to 0. So if I set 2x squared plus 1 equal to 0, we solve this. We're going to get 2x squared. We'd subtract 1 from both sides, would equal a -1. Then we divide by 2 to get x squared equals a -1/2. Well, think about this. Can a value that is squared ever be negative? It cannot, because when you square a value, it will always become positive. So, and you could find that by trying to take the square root of both sides, and you'd have a square root of a negative number. So we'd say there are no zeros. What that means is there are no x-intercepts. The next step below said to substitute 0 in for x to find your y-intercept. So to find my y-intercept, we find g of 0. So we're going to substitute 0 in and have 2 times 0 plus 1 over 0 squared. Whoops, can't have 0 squared, so there are no y-intercepts either. So, wow, that didn't seem to help us very much, except we know that we're never going to cross this line and we're never going to cross that line. That can help us very much. Let's go ahead. Our last step to graph a function is to substitute some points in. Now, I recommend substituting some points to the left and to the right of your vertical asymptote. So if we substitute a point in to the left of x equals 0, maybe we find g of -1. If we substitute a -1 in, we'll have 2 times a -1 squared plus 1 over a -1 squared. That's going to give us 2 plus 1 is 3 over 1, so 3. So at -1, we're at 3. Okay, we pretty much know how to graph this now, because we know that our curve is going to approach these asymptotes but it's not going to cross them. So it has to kind of do this because it can't go down because it can't cross this horizontal asymptote. And like that. Now let's try a point to the right of my vertical asymptote. Maybe we'll try g of 1. G of 1. We substitute 1 in. We're going to have 2 times 1 squared plus 1 over 1 squared. Again, we're going to get 3 over 1, which is 3. So we have the point, this indicates the point 1, 3, right here. Again, we're not going to cross the horizontal asymptote. We're not going to cross the vertical asymptote. So what has to happen is that function looks like that. So you have to kind of use some intuition around your asymptotes. Let's try a few more. All right, so here we have this one, and we'll follow the steps above to try to determine our asymptotes. First, we find any real zeros of the denominator, and this will sketch our vertical asymptotes. So our vertical asymptotes will be when my denominator equals 0. So we can either factor this, factor it, that would be an easy way to solve it. Or if you can't know how to factor that, you can use the quadratic function, which would be to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and either factor this or solve the quadratic function to find your vertical asymptotes in number 7. All right, if you were able to factor it, you would get 3x minus 2 times x plus 3 is how this factors. That leads us simply to setting 3x minus 2 equal to 0. So 3x would equal 2, dividing by 3, x would equal 2/3. Or that x plus 3 equals 0. Subtracting 3, we'd get x equals a negative 3. That is a nice, convenient way. Now, if we needed to use a quadratic formula, that works also. We'd substitute the values in. Inside the square root, you wind up getting 121, which is 11. So we have a negative 7 minus 11 over 6 is a negative 18 over 6, or negative 3. And we'd have also a negative 7 plus 11 over 6, which is 4/6, or 2/3. So you can see we wind up getting the same values. That leads us to our asymptotes, our vertical asymptotes of x equals negative 3 and x equals 2/3. Now, the other thing we need to do is find our horizontal asymptotes. Let me erase this and we'll look at that. So remember, to find our horizontal asymptotes, we look at the degrees of the terms. Now here, the degree of my numerator, 2x plus 3, is just 1. And the degree of my denominator, 3x squared plus 7x minus 6, is going to be that 2. So since the numerator has a degree 1 less than the denominator, my horizontal asymptote from above is just going to be y equals 0, because the degree of the numerator is less than the degree of the denominator. So we're going to plug that, we're going to write that right in here, and that's that horizontal asymptote. Now, now we want to find any zeros of the function, and again, we said we would do that by setting my numerator equal to 0. Now, zeros of the function are where the function crosses the x-axis. So if we set the numerator equal to 0, and we subtract 3, and divide by 2, we get x equals a negative 3/2. So function x equals a negative 3/2 is a negative 1/2. That is a point on my graph. To find the y-intercept, we substitute 0 into the function. So the 0 is the same as the x-intercept, and the y-intercept will be found by substituting 0 in. So we'll have 2 times 0 plus 3 over 3 times 0 squared plus 7 times 0 minus 6. Since these terms become 0, we're left with 3 over a negative 6, or my y-intercept then would be a negative 1/2. So 0, negative 1. And that's going to be right there. Okay, let's use some logic here. It looks as though, so we do know a couple things. That is my only y-axis intercept. So I know that this curve is not going to cross, I'm sorry. My only x-axis intercept, let's go back up here, is -3/2. This one right here. So I know that this curve is not going to cross this x-axis again, which means that it's got to do this, approach that asymptote this way, and approach that asymptote that way. We know we're also not going to cross the x-axis again over here because my only x-intercept is -3/2. Now we only have to determine the ends, what's going on to the left of my x equals -3 vertical asymptote, or what's going on to the right of this x equals 2/3. So we just substitute a value in. Let's substitute x equals -4 into this function. So if we find f of -4, that's going to give us 2 times -4 plus 3 over 3 times -4 squared plus 7 times -4 minus 6. Let's see what that is. Finding that value, we get a -5/14. So that's at -4 here. This is 1, 2, 3, 4. We're at a -5/14, which is not quite a -1. Now I know I don't cross the x-axis or the y-axis, the x-axis or this vertical asymptote. So I know the curve is going to look like that. Now let's determine what's going on to the right of 2/3 by plugging in maybe x equals 1 to find the y value there. When you substitute in 1, you get a y value of 5/4. So 1, we're at 5/4, which is 1/4. Now I know I'm not going to cross this vertical asymptote nor this horizontal asymptote. So this graph is going to look like that, although it keeps approaching that x-axis. All right, we're going to try a couple more in our next video. Thanks for watching.